Hello and welcome. In this lesson we are going to look at the concepts behind logical volume management. I'll let you know right up front we're not going to do any practical application of it in this video itself. This is just sort of the theory video to describe the underlying concepts. So we'll learn about the concepts behind logical volume management, which will eventually, once you actually do learn about the practical application, allows you to more flexibly manage the storage in your machines. And I'll let you know, again, right up front, setting this up does require a little bit more work initially, but it really does pay off in the long run. So logical volume management is a tool for system administrators that is going to allow us to more easily manage file systems, including potentially the ability to manage them while they're running, while the machine is on and people are logged in and using them. And what it does is provide a layer of abstraction between what we're doing with mounting a volume into our file system and our users actually accessing it, and the underlying physical hardware that represents the disk drive. So it's just a way of allowing us to manage our physical storage and partitions by, well, adding in a logical software layer to provide more flexibility, more complex storage schemes, and very importantly, allowing for easy growth of our file systems. And this could be things like having one file system that appears to our users as if it is a terabyte disk, but in reality it's stored on 4 250 gig drives. Or we could take that one physical 250 gig drive and divide that into 5 50 gig volumes. Yes, you could do that with the older style of file system management, but I'm just pointing out we can still do that with LVM. So this is the major things that we're going to be working with in LVM are physical volumes, volume groups, and logical volumes. Physical volumes are partitions of our disks that are specially marked for use with LVMs, or with LVM. So it's a partition, just there's an extra flag set in it saying this is ready for logical volume management. These then get combined into volume groups. These are pools of storage that consist of one or more physical volumes. And that's really important because that then allows us to portion those out into logical volumes, software-defined. I'm not sure whether I should use the word partition or volumes here, but software-defined portions of storage that we then mount into our file system. To a user's perspective, these will still appear as just a regular portion of the file system, but for us working behind the scenes, we can move these from one hard drive to another. We can easily expand them by adding in more space. They are, in effect, a virtual disk. So again, a physical volume, it's a disk, whether it's a physical drive or a portion of storage that you've set up for, say, a virtual machine, and the partitions we've created on it. With LVM, we're not so concerned if it's a full disk or it's a partition of that disk, just it's this amount of space that we have marked for use in logical volume management. And that is a really, really important step that I will repeat once we actually get into the practical portion of this. Just making a partition, it's just a partition. You have to set a flag in that partition to say this is ready for logical volume management. Otherwise it won't work. So we have this nice rectangle representing a disk. Let me say, draw a nice loop around that. We have a disk, and I have divided that up into two partitions, one 10 gig partition, and I should probably draw thicker lines, one 40 gig partition. We can then take that 40 gig partition, we set a flag and say this 40 gig partition represents a physical volume. It is a partition that is ready to be used in logical volume management. And that brings us to a volume group. And a volume group is just a collection of physical volumes. We give it a name, and we say all of these physical volumes belong in this group. And that creates a storage pool, the combined amount of storage from all the physical volumes we've put into this, that we can then portion out as needed. So if we took two of our physical volumes, one at 40 gigs, one at 90 gigs, we can then combine those together into a volume group that represents the combined storage of all of that. And of course, this wouldn't necessarily be limited to just two. You could have 3, 4, a dozen physical volumes, depending on how complicated your storage needs were and how many drives you were drawing this from. Once you have that storage allocated as part of a volume group, you can then portion it out as needed into logical volumes. These are effectively virtual partitions. They're still taking up space on your disk in that physical volume eventually, but we're a step removed from having to worry about what partition is it actually on. We're just saying take X amount of space from this volume group and assign it as this software-defined volume. Once we have that, we can then format it and mount it on our file system just like any other volume. So we could take this logical volume and attach it to /home or /var or whatever else. And I mentioned this earlier, this does take a few extra steps beyond just making a partition, formatting it in whatever format, and saying that's my /home. By using LVM, this is going to allow us to have more complex storage schemes, like say if I have several disks that all have 50 gigs of space available on them, I could combine those into one volume group and set that up as maybe just one single logical volume that is the combined space of all of those. Or, and here's the really advantageous bit where this is going to pay off in the long run, this is going to make growing, shrinking, or even transferring a logical volume from one disk to another much, much easier. Instead of having to plug in a new drive and then effectively do a bit-by-bit copy from one drive to another to, if the one drive was failing and I want to get all that data onto another, instead of having to manually copy it all, I can just add more space into my volume group, add that space to my logical volume, and then specify I want to take this failing disk out of my volume group, and LVM will automatically take the data that was on that failing drive, move it into my other physical volumes that are part of that logical volume group, and I don't have to worry about copying it myself. So putting this all together, we started off with our physical volumes, which were specially marked partitions of a drive. We combined those together into a volume group of, that combined amount of space, and then we can portion that out into logical volumes of whatever size that we need. And we can easily resize or remove or add those later on as needed. So, what we've looked at in this lesson is just a quick overview of the underlying concepts behind logical volume management, the three major types of objects that we're going to be working with: a physical volume, a volume group, and a logical volume. And you're going to need this to understand the commands that we use in logical volume management and to actually implement a logical volume management scheme, which we'll do in some later videos. And I already said this, yes, this is going to require a little bit of extra setup that you didn't see in traditional volume management, but this is going to make management of your storage much, much easier in the long run. It'll allow you to adapt to unexpected things or having to resize volumes very, very easily. I've also got a link on the last slide here that I will throw in the description. This is a pretty good tutorial for the entirety of, well, not the entirety of using LVM, but it will get you to a point of being able to use LVM yourself. It will cover much of what I covered here, along with the commands and operations that you'll use to actually implement logical volume management. So I would certainly suggest checking that tutorial out. It's good. And as I mentioned, I will have several more videos after this one where we do actually continue with the rest of this and actually implement logical volume management. So thank you, and I'll see you there.